We define trig functions using the historical methods through right triangle. And so here's the angle theta, and then the wall opposite to it is called opposite O, and the floor is the adjacent. And then you have tilde side, that's the hypotenuse. We have sine is defined to be opposite over hypotenuse. Cosine is adjacent over the hypotenuse, and tangent is O over B. Hence, like the SOHCAHTOA. And notice that this ratio does not depend on the size of this right triangle. It depends only on theta. And when theta is 0 degree or 90 degree, we have these two very skinny triangles, and then you can go look through these and then extract the sine, the trig values, and we get this list of trig values. The other trig values that we can find easily are related to two special triangles, 45, 45, 30, 60 degree triangles. 45, 45, then we can read out the sine is going to be root 2 over 2 divided by 1. Same thing as cosine, because these two sides are same. Then tangent is 1. And for the 60-30s, then the sine will be looking at 1/2 over 1. And so we get this list of triangle trig formulas. In particular, if I use pi over 3, the same triangle, then I get this list of angles. We can find the trig values very easily. The other ones we use calculator. So then with these are calculation problems using calculator. For instance, if I have a right triangles like this, how do I fill in all the other measurements? Well, then the first things is that the angle over here is 56 degree. Then I can use, for instance, tangent, and say tangent of 56 is going to be b over 23, and then we get these formulas done by calculator. I get what b is. And similarly, to find out c, I can use the formula sine of 34 is 23 over c. Then solve for c using calculator. And here on part B, I got two sides of right triangle. First thing you can do is find out what A is using Pythagorean theorems. Then find out A is root of 57. Then I can extract all the others, the value of sines and cosine. Okay, and so here they are. Apply problems. When we look up something, with that angle we look up is called angle of elevations, and the thing looking down at us, and then it will be that angle for the respective thing to the cat. For the cat, its angle is an angle of depressions downward. Okay, and notice my angle of elevations is same as a cat's angle of depressions. Okay. And here is a problem. A drone fly from straight toward whales, big fish in the oceans, and he traveled 20 feet, and then the angle of depression changed from 56 to 46 to 56. And how high is the drone flying? Well, first I can use the tangent again, and the h over x is going to be 50-60 degree tangent of that, so I can solve for h, and that's the equation in h. Then, but if I look at it for the first 46 degree perspective, then the tangent of that is h over x plus 20. So tangent of 46 is equal to these, and I can solve for the h. Then I can put these two together, eliminate the h, and these give me a full equations in tangents, and remember in x using tangents, and these two are numbers, so algebraically can solve for x, and then I get to this is called the exact equations, and this of course is called the numerical equations, answers. Okay, and here I have two buildings looking up and one looking down. One it has 120 feet, and the angle of elevations is 86, and this is 72. And so find out how big is the building on the other side. So I'm going to let x and h be as shown. Then from the perspective of the 72 degree, and this the same angle as this, is the tangent of 72 is 120 over x. So I can solve for the x first. Once I find out what x is, then I can find out what the h is in terms of tangent of 86. It's going to be h over x, and I can solve for h. And so this is the answer. Okay, that's it. Bye-bye. Okay, stop sharing.